All right, I'm Mark Mitchell. For my advanced integral problem, I was given the integral of x plus 16 over x squared plus 2x minus 8 times dx. The biggest thing we can see here is that this is not only a fraction, but a little bit too complex of a fraction to immediately integrate. So the very first thing we're going to do is break it up. First of all, we take the denominator. We have x squared plus 2x minus 8. We can break that down with x times x is x squared, and then plus 4 and minus 2 will both produce the minus 8 at the back and the plus 2x in the middle. You can see the math laid out here. X times x is x squared, x times minus 2 minus 2x, plus 4 times x plus 4x, plus 4 minus 2 is minus 8. Simplify that down, and we have our original. That means that we are left with x plus 16 over x plus 4 times x minus 2. For the time being, I am leaving out the integral and the dx just to keep everything simple, to keep our focus on these numbers. We will bring them back in. Now, that's about as simple as we can get that with our normal methods. Now we have to do some very weird fraction decomposition. But going through it step by step, it's still relatively logical. We have this fraction. The issue is it's a complex fraction, and we basically have two of these multiples in the denominator now. What we want to do is break them up, but we can't do that by traditional methods because we have x plus 16, which breaks up really, really weird. So all we're doing is basically we are taking this, we are setting x plus 16 equal to, altogether now, a over x plus 4 plus b over x minus 2. The basic principle here is, even though the things that x plus 16 breaks up into are very strange, we don't actually need them to solve for this. We just need to know that mathematically there are two things that come together into x plus 16. So we can just represent them by a and b, and we're fine. To make this more applicable, really, we have a over x plus 4 plus b over x minus 2, right? We don't want this here, so we're just going to multiply by this on both sides. And so we are ultimately left with x plus 16 is equal to all of this, right? Now, we've got that. We can move straight in to simplifying. Just focusing on what we've got in front of us, we can break it up. We can multiply out so that it's a over x plus 4 times x plus 4 times x minus 2 plus b over x minus 2 times x plus 4 times x minus 2. We can immediately see that x minus 2 cancels out and x plus 4 cancels out, leaving us with a times x minus 2 plus b times x plus 4. Bringing this back in, we see that x plus 16 is equal to a times x minus 2 plus b times x plus 4, right? Now, we're trying to figure out what to do with this. The most logical thing to do is we can try and find zeros. What we need to do at this point, we don't even need to solve for x. We need to solve for a and b. It's weird, but it's going to help us when we come back to the full problem. So, if we look at x plus 4 times x minus 2, which was the denominator of our original, and set that equal to 0, it's pretty easy to see that our zeros for this are x equals 2 or x equals negative 4. All we're going to do is take this equation and plug in both of those values. We're going to find what we get for a and b. It doesn't look at first like we're going to be able to do that because we still have both a and b in the problem. But because these are our zeros, and because both a over x plus 4 and b over x minus 2 were based on the original, we're able to plug them in, and we'll find that when we plug in negative 4, which is the 0 for this half, we're able to get the value of a as negative 2. And when we plug in 2, the 0 for this half, we're able to get 3 for b. That means we now have the values for a and for b. Now, what's that going to get us? Well, it allows us to move into our final steps here. We get to solve. It's not much, but it does require some explanation. First, we're back where we started. All this and that would have a dx tacked on at the end, right? Now we can set that equal to the form we've been dealing with this whole time. We can set it back to, if we look back and translate this back, the a and the b forms, but we now have those values. We can plug in our negative 2. We can plug in our 3. And now we've got these very dealable, integratable fractions. Just by processing those down, we end up with negative 2 times ln of x plus 4 plus 3 times ln of x minus 2, and you have to tack on the plus c at the end. We've dealt with our integral, we've dealt with our dx, and this is as good as we can get our final answer. So now, just to repeat, we are left with negative 2 times ln of x plus 4 plus 3 ln of x minus 2 plus c. I really hope that's right.